Integration by parts. It's also known as integrating the product rule. Why would we want to use this technique? Well, let's have a look at an example where all the other integration techniques don't work, namely x sine x. We can't use integration by substitution, integration by trigonometric substitution, inverse trigonometric substitution, the half-angle formula, or partial fractions. So what do we use? Well, you'll have to understand that we need to use a different technique here, and it's actually a technique derived from the product rule. So if we integrate the product rule, what we will get is something like this, and we can actually match it to the function we're trying to integrate. So we use integration by parts when we have two functions that are together. So you'll see that we need to find or give ourselves a u, something in terms of u, and the function that we can choose is x, because if we derive it, then we'll just get 1. And then our v prime dx is just sine x dx, as you can see here from our formula that we derived, and if we integrate it, we'll just get v, which is minus cos x. So if you substitute all of that into the formula and simplify it, you'll get sine x minus x cos x plus c. And there's all the working out. So let's have a look at another example. X e to the 2x. So I make it a habit to derive the product rule, derive the integration by parts formula from the product rule, because it doesn't take long to do, and it does get you in the mindset of what functions you should choose for v and which functions you should choose for u, because this is important. So see how v prime becomes v, and in order to do that, it needs to be integrated, and see how u becomes u prime. In order for that to happen, u must be differentiated. So when you're looking at more complicated functions, it's important to think which should be v prime and which should be your u. So our v will be integrated and our u will be differentiated. I'm not sure what version of the integration by parts formula you have, so it's important to check that your formula that you're looking at is the same as mine. So this is why I like to derive it, so I know exactly what my v is and what my u is, because it can get confusing. So I've chosen to integrate e to the 2x and to differentiate x. So as you can see, we substitute these values into our formula and we integrate this function and we get this back. And you can leave your answer like that, or you can take out the fractions to make it look neater. So I think you've gotten the hang of it, you get the general idea of it. The next example will require you to think outside the box. They may or may not include this type of question in exams, so it's a good idea to understand it. So ln x squared, how do we integrate this? What is our u and what is our v? So I'm not going to run through this step again, I know you understand it. So what will our u and v become? Because we don't have two functions, we've got ln x and ln x. So is that what we do? Do we just put v as ln x and u as ln x? You could, but there is a quicker way. See if you can think from a different perspective, and I'll give you a hint. Which functions are equal to 1? So I've chosen to let our ln x be the function that we differentiate, so our u. And our v is not ln x, but it's x to the 0, because any function to the power of 0 is 1. And if we integrate that, we'll just get x back. So now we substitute all of this into our formula that we derived, and we cross out x and x, and we take the coefficient out to make the integration process easier, and then we know from our formula sheet that ln x is this function. So then we have completed our integration. This is our answer. So now let's do a more challenging example. Let's try integrate this one. Now you're probably thinking that the trick is it's something to do with the definite integral, because all of we've been integrating are indefinite integrals, but that's not the case. You'll see what I mean when you try to do it. So pause the video, give it a go, see if you can figure it out. If not, then it's okay. I've got the explanation here. So, as always, I make it a habit to write down how to find the integration by parts formula because it takes like 2 seconds. And I also like to write down which will be integrated and which will be differentiated. So I've let u be the one that I differentiate and my ex be the one I integrate because ex just stays the same. Now we substitute that into our formula and look, we have to do integration by parts again. Okay, that's fine. We know how to do that. So I've let my v prime equal to ex because if I integrate it, just get ex back and minus sine x as my u, which I will differentiate. So now we substitute it into the formula and oh my goodness, we gotta integrate by parts again. How many times do we have to do this? Do we have to do this forever until we rate? Because look, it's just gonna keep happening like this. So is there a trick? Yes, there is. So no, we don't have to do it again. So let our original function that we're trying to integrate equal to a. Don't worry about limits at this point. So remember how we found out the integration by parts for the first round. The first time that we did it was this function. That means a will just be equal to this. And then remember we integrated by parts again. And this is the formula we got. And notice how we actually got our original integration equation in the second time that we integrated by parts. So this is what this simplifies down to, e minus e to the x sine x plus e. So now we put it all together. And what do we find? We find this, that our a is just equal to a half of our combined equations. So what was our a? Our a was our original function. So we have actually evaluated the integral of this function, just not exactly directly. We did have to do some substitution. So now we can put the limits in because we figured out what the integral is of this function. Without the limits, putting the limits in is fine. We can still use the function that we found. And now we can evaluate it, and the answer is e to the pi plus 1 over 2. So to summarize, integration by parts involves integrating the product rule. You need to pay attention to which value you choose for u and for v, as one function is always easier to integrate than the other and will save you time. So hopefully you've learnt some tricks and realised that it's not always as straightforward as it seems. So this concludes the series on integration. So I've covered all of these topics. Feel free to go on my channel and rewatch them as many times as you like.